Welcome back to HVAC Talk with Huff. I'm Huff. We're back today in front of Johnny 5. That's what I affectionately call this trainer unit here. And we're ready to do our second round of testing. Our first round of testing, we actually started by creating a baseline using the washable type filter that actually came with this air handler that's 16 by 20. And then we swapped that out for a Merv 11, 16 by 20, about 1 inch, and then also a Merv 13. The measurements we were looking at during that testing were we measured the pressure drop across the filter. In other words, how much restriction did that filter cause as the air was going across it. We also measured the total external static pressure. That's the total force exerted upon the blower of this air handler. And then we also compared the wattage back here on our wattage meter. And so we set a baseline with that washable type filter. And then as we took those measurements for the baseline, and then we compared the same measurements again with the Merv 11 and the Merv 13. If you haven't watched that video yet, I would suggest you stop right now and go watch that video. There'll be a link down in the comment section, and then come back and watch this one. Now, again, we are using, just to recap very quickly, this air handler, we are using a what we call variable speed air handler. Technically, it's known as an ECM, electronically commutated motor, and this is what we call a constant CFM motor. What that means is, as we increase pressure exerted against this blower, it will actually increase the blower speed to account for it so that it delivers a constant volume of air that we program. This particular one has a control board in it that also talks to this communicating control. And so the constant CFM motors they're able to ramp up against what we call static pressure to deliver that constant volume of air, even if the pressure exerted against it increases. Now, when we get done this round of testing, we're actually going to take this motor out and put in what's known as a constant torque motor, and we're going to do the same kind of testing. That'll be coming shortly. So what's important to know is that even as we swap these filters out, this blower is going to adjust to deliver that constant volume of air. And then HVAC, we measure that air volume in what we call cubic feet per minute. So I've already got a Merv 11 Aprilaire filter installed in the system here. In the return that you can see here, that door down there. Now what we're going to be doing today is not stepping up different type of filters. What we're going to do is we're going to do a heads up filter comparison. We're going to compare that Merv 11 Aprilaire filter, which is actually 4 inches deep. You can see here, this is actually the Merv 13 version. But it is 20 by 20. So now we've increased filter size. We went from a 16 by 20 now to a 20 by 20. And this is 4 inches deep. And then we're going to compare that to the same diameter outside dimensions as far as 20 by 20, but only 1 inch deep. So we're going to compare the Merv 11 in there, 20 by 20 by 4, to this 20 by 20 by 1. And then we're going to do the same thing for the Merv 13. And what I'll do is I'll show them on the screen side by side in comparison so you can see the results. Again, what we will be measuring is the same as we did last time. We'll be measuring the pressure drop across the filter. We'll be measuring the total external static pressure exerted against the blower, and also the wattage consumption of the blower as it increases itself to account for these filter types. All right, folks, we got the system back up and running, and we have our air blowing, we got our filter in, and we see readings that are showing up on our manometers. On the original testing, I actually had the return duct dampered back a little bit on our first test to basically simulate a normal type of duct system and not one that's got this oversized return that I did on purpose for this filter that we're testing now. And so I dialed it back so that the external static pressure with the washable filter we dialed it in about 0.42. Now that's still low to be quite honest with you. The air handler is rated at 0.5. We do allow for a percentage of increase above that, but we try to design to that. So I actually, to make sure that we didn't skew any results, I actually had the total external static pressure dialed in a lot, actually lower than what we typically see in the field in most duct designs these days. It's rare that we find one with a lower static. It's usually higher. So I wanted to make sure that that test was realistic. Now that we're using the larger type filters, I actually have everything now wide open, and you can see that we're going to see that our static that we're running today is almost what it was with the first test that we did with those that smaller washable filter, which is kind of what we designed for. So let's get started. So now you should be able to see it in the screen. So our return static is running at 0.09. That's the static pressure before the filter. After the filter, we're running 0.21. So we got a filter pressure drop of about a 0.12, 0.13, something like that. I'll have to do the math when we do that portion, we do the actual comparison. And then we also have our supply static. This is the static on the supply side of the blower, and that static is running at 0.15, 0.16. So this is our Merv 11 20 by 20 4-inch deep filter. Our power consumption right now is running at about 138 watts, 137.5. It bounces just a little bit, but 137, 138. And so that is our wattage consumption for this setup here. And so this is 20 by 20, Merv 11, 4-inch wide filter. Now what we're going to do is we're going to leave airflow situated exactly the same. Right now we're flowing about 728 cubic feet of air per minute across this filter and through this system. So we're going to leave everything the same, except for we're going to change this, take this 4-inch filter out, put a 1-inch filter in that's the same rating, Merv 11, and see what the readings are with that filter. All right, folks, we got the system back up and running. We have our 20 by 20 Merv 11 1-inch filter in. Let's take a look and see what we have. The return static pressure before the filter is still at 0.9. However, our static pressure after the filter has now increased to 0.33. So now we have about a 0.24 pressure drop across the filter, which is almost double what it was with the 4-inch wide filter. And our supply static is still running about the same, which is 0.15, 0.16. Now, our power consumption has increased now to, it's bouncing between 168 and 169 watts of consumption for the power. What we're going to do is now take this information and we're going to put it together and show you side by side on the screen through a recap of just how it changed to go from Merv 11 20 by 20 4-inch wide to 20 by 20 1-inch wide. And so this is a difference of a professionally installed April air filter in this case versus a 1-inch that I can buy at the Home Depot. And that's where I bought these filters. These filters are HDX brand, sold at my local Home Depot, which is the closest retail chain near me as far as selling filters is concerned.
Now for a recap. We tested two Merv 11 filters at the same airflow volume of 728 cubic feet per minute. Both were 20 by 20, however one was 4 inches deep and the other was only 1 inch deep. Same rating, same size, different results. Here's what we measured. Filter pressure drop. That's the resistance the filter puts in the stream of the airflow. The 4-inch deep filter measured 0.12 inches of water column pressure drop. The 1-inch deep filter measured 0.24. That's a 100% increase in filter pressure drop. Next, total external static pressure. That's the total load that your blower is experiencing as it's moving the air. The 4-inch filter measured 0.37. The 1-inch filter measured 0.49. That's a 32% increase of total external static pressure. And lastly, fan wattage. That's the amount of power that your air handler is consuming as it moves the air. The 4-inch deep filter measured 138.5 watts. The 1-inch filter measured 168.2. That's a 21% jump in power consumption just from the filter change. Same Merv rating, but that 1-inch filter is costing your system and your customer more energy, more wear, and more static pressure every single day that it runs. Filter depth matters. Now you have the data to prove it.
All right, folks, we now have our 20 by 20 by 4-inch Merv 13 filter installed. Again, blower calling for the same amount of airflow. We're running about 728 CFM through the system right now. So let's go to the gauges. Return static before the filter, still 0.09. it's bouncing a little bit, 0.08, 0.09. On the other side of the filter is running 0.24, 0.25. That means we have about a 0.14, 0.15 pressure drop across the filter. And then on our supply side, we have a 0.16, 0.17. And so that's giving us a total external static pressure here of a little over 0.4, little over 0.4, I think. We'll do the math and we'll put it up in the screen and do a recap for you so you can see those numbers, and we'll do all the comparison. Now, when we do the math, we're actually round to the second decimal point, so that it's nice and sleek, and make sure that everything is kind of measured equally. And then our wattage consumption back here is we're running right about 150, 151 wattage consumption with this Merv 13 filter. So this is really great performance for a Merv 13 filter in our system. But again, it was accounted for. When we tried to run Merv 13 into this 1-inch filter slot, which is actually also smaller, instead of 20 by 20, it was 16 by 20, we saw a huge increase in wattage consumption, total external static pressure, and pressure drop across the coil. And so now we're looking at this professionally installed Aprilaire Merv 13. Now, there are other brands other than Aprilaire. It just happened to be the one that I kind of am used to and I like. There are other filter manufacturers that have the same Merv rating, same style. But again, the 4-inch wide filter is part of the key here. They even make filters even higher than Merv 13. The dust-free 16 comes to mind. And our industry friend, John Ellis, developed that, and you can go and look that up online. Again, but these type of filters, to do it right, to not overtax the system, to be able to run these and not consume more power, they have to be planned for and accounted for in the duct design. So we're going to do a video just about this duct configuration and why we did it that way on another video. So now we're going to take this 20 by 20 by 4 Merv 13 out, and we're going to put the 20 by 20 Merv 13 1-inch in, and we're going to read those numbers as well, and then we'll do the recap. All right, folks, we're back. We got our 20 by 20 by 1-inch Merv 13 filter that we got from a Home Depot, and let's take a look at what we got. Still running about a 0.09 on our return before the filter, but after the filter, we're now up to 0.41. Now, what does that mean? That means we have about a 0.32 pressure drop across this filter, which is definitely an increase over the Merv 13 20 by 20 4-inch filter that we started with. Our supply static still running about the same, 0.16, almost 0.17. And so now our total external static pressure now, though, is running close to 0.6. So we increased our pressure drop, we increased our total external static pressure. Now let's look back here at the wattage monitor, and our wattage consumption is 189, 190 watts. So we definitely increased our wattage consumption as well. And so when we go from that, if we take that Merv 13 1-inch filter and compare it to the Merv 13 4-inch wide filter of the same outer dimension, 20 by 20, definitely the 4-inch filter well outperforms the 1-inch filter as far as its tax on the system. In other words, our pressure drop is lower, our total external static pressure is lower, and our wattage consumption is lower. And so a professionally installed high Merv filter is the way to go, and it needs to be accounted for in the duct design. So that means they may have to reconfigure some of your return duct to account for it. And yes, there will be a cost associated with that. However, overall, your system is going to breathe much better, perform a lot better, and you're going to get the filtration that you actually want. And so we would call that a win-win.
Now for a Merv 13 comparison. Filter pressure drop. Our 4-inch Merv 13 was 0.16 inches of water column. The 1-inch measured 0.33. That's a 106% increase. Again, more than double the resistance. Total external static pressure. The 4-inch filter measured 0.42, where the 1-inch deep filter measured 0.58. That's a 38% increase in total load on this blower. And lastly, power consumption. The 4-inch deep filter measured 146.8 watts, and the 1-inch measured 178.1. That's a 21% increase, over 31 extra watts every time that your system is running. The Merv 13 is a great filter, but the denser the filter, the more surface area it needs to breathe. A 1-inch Merv 13 is like putting a high-performance air filter on a car and then crimping the intake hose. You're getting the filtration, but you're choking the airflow. A 4-inch deep filter gives the same clean air with a fraction of the resistance. Merv 13 is a gold standard for home air filtration. It's great for allergies, great for air quality. But if you're running a 1-inch Merv 13, you might be doing more harm than good to your system. Not to mention that 31 extra watts running 8 to 12 hours a day, every day in the cooling season, maybe even more at the height of the season, that's real money. Plus the added wear on the blower motor that's constantly overworking.
Stay tuned, because the next round of testing, we're actually going to take this blower package out, this constant CFM, and we're going to put in a constant torque motor. The constant torque motor is not going to ramp up like this motor does. When you apply additional static pressure to it, it tends to slow down. Right? So it'll start to slow down a little bit as the static pressure increases. And so what happens when that occurs is that our amount of airflow, our cubic feet per minute, is not going to stay the same anymore. So as we start to apply static pressure and we start to increase that, our airflow is going to decrease. And so stay tuned for that video. We're going to do the filter slot again and do the round with the washable, and then our Merv 11 and Merv 13 16x20. Show all the testing, and then we're also going to do this test with that as well. So stay tuned for that. We got 2 more videos coming just in filter testing alone. Talk to you soon. Oh, don't forget, if you're able, or if you like, or you want to support this, hit that like and subscribe thing, and it does help us out, and so we would appreciate it.